Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Melia Science.
Today we are going to do some pumpkin experiments. First, we're going to have to dissect this pumpkin. We're going to dissect him and find out what's on the inside. And then we are going to make a volcano on him by making a chemical reaction inside of him. All right, so let's look at the parts of a pumpkin. Well, we got the skin. This is the tough layer. Sometimes people like to cut into the skin to make funny faces. And then under that, we have the pulp. I'm cutting his head off. Oh no!
That's his brain.
Pumpkins don't have brains.
That's offending.
I hope this one doesn't have a brain. This is the little piece of the pumpkin's vine. This is the pumpkin stem. We need to get inside. Now, is a pumpkin a fruit or a vegetable? Well, we grow them in a vegetable garden, but a lot of the things that we grow in a vegetable garden are actually fruit. A fruit is a plant where the seeds are in the inside of something yummy to eat. Ooh, look at all these strands and pulps. And these are the seeds. This is the fruit. And the pumpkin is around the seeds. We eat whatever's wrapped around the seeds, it's usually a fruit. If we eat part of the plant, like celery, we eat the stem, or carrots, we eat the roots, then those guys are vegetables. So even things like tomatoes are fruits. But we don't put them in fruit salads because they would taste yucky. All right, we are going to hollow him out a little bit.
Well, it's gonna turn into a volcano anyway.
Alrighty. Oh boy, there's lots of good stuff in here. Look at all these seeds. If they all land into the, why do you think they have so many seeds? Well, this is their way of having a chance of growing another pumpkin. If you have a whole bunch of seeds like this, it's pretty hard for a pumpkin seed to land right in the right spot. So, to grow perfectly, away from other big plants that would block out the sunlight, away from right on good soil. So they have a whole bunch of seeds with the chance that maybe one of them will make it into a new pumpkin plant. Now humans help this process out a lot because we gather the seeds to plant new pumpkin plants next year. Some of us do. Some of them gather the seeds and eat them. Fry them up and eat them. They're yummy.
Right now they're drying out.
So, we got lots of seeds in here. Holy mackerel. We'll speed this part up.
Mr. Al Science Show, and he is a crazy guy. He's actually pretty fun to play with. Well, yeah, he's like smart, like he's like crazy.
We're going to put some baking soda and some vinegar and maybe a little soap inside this pumpkin and see if we can turn him into a pumpkin volcano. All right? See what happens. Hope it's not. Oh! All right. So let's go. Let's take a look. What is going to happen scientifically here? This pumpkin told me when he was little, he always wanted to be a volcano. So, because he said volcanoes are much scarier than jack-o'-lanterns. So, let's look at what's going to happen. The baking soda here is a base. This is a base. It's sodium bicarbonate. Probably says it somewhere on the direction or on the ingredients, but it's sodium bicarbonate. It's a base. And the vinegar is an acid. You know, it's a diluted acetate. It's just, it gets on your skin. It's not going to burn you, but it is an acid. And when we mix them together, guess what's going to happen? We're going to have OH combined with H, OH combined with H, and it's going to release water. It's going to make water, because then you're going to have two H's and one O, two hydrogens, one oxygen. It's going to make mostly water, hydrogen or H2O. So, but that's not very exciting. All right, that's not very exciting. We got the hydroxide and the hydrogen, and it's going to make water. But that's not exciting. What the exciting part is, during that chemical reaction, you're going to make carbon dioxide. Carbon dioxide is the bubbles. These bubbles that are going to form and fill up space and space and space until the pumpkin can't hold them more. It's well, probably not, but at least fizz and foam out. Hopefully. Hopefully. And we might add a little soap suds just to make things a little more bubbly, because there is going to be water in there. I'm going to add a little of this. Hopefully not too much.
Seems like a crazy scientist.
Going to add a little of this.
You gotta put it.
Oh boy. And finally,
The vinegar. Uh-oh.
oh, I hope this doesn't get on the rug. Oh, lots of cool stuff is happening in there, but not much. I can see. I've got it popped on. Don't worry. It's safe.
Let's see if
It's not going to erupt.
Let's see if it falls off.
Hmm.
Add a little bit more.
A little more, you say?
Yeah.
I'm coming to get you, Barbara. I'm a volcanic pumpkin. I'm so happy.
Oh, the soap is fizzing out.
So, basically, we had carbon dioxide, or a base and an acid, releasing carbon dioxide. And we got a volcanic pumpkin. Let's put a lid on it. Oh no, he's coming out.
It's still coming out. He's bleeding.
All right.
Man, he cracked his head open real hard.
Well, we cut his head open. All right. So basically, again, what happened there? We hollowed out the pumpkin. Oh, look, he's breathing. Ooh, pretty cool. We hollowed out the pumpkin. We added a base, which is our baking soda, and an acid, which is our vinegar, and then that made a chemical reaction that produced mostly water. Because there's an OH and an H, they go together, you get H2O, that's water. But when that happened, a lot of carbon dioxide was released. And that carbon dioxide is the same thing that you see when you shake up your pop can. So nothing too dangerous there. But we got to get rid of this, or if this gets on the rug, Mrs. Ingro is going to really be dangerous towards us. So we better clean this up quick. Next up, we're going to make a pumpkin out of candy using hot water. Now, we're going to do something a little different. You could do this one at home. You could do the last one at home. But this one's a little bit different. All you need is Reese Pieces and hot water. I had 2 bags full of Reese Pieces, but somehow some of these disappeared. Maybe one of my little gremlins had a couple. All right, this is pretty easy. What I'm going to do is get a dry plate, and I am going to make a pumpkin out of my Reese Pieces. All right, there's 3 states of matter: solid, a liquid, and a gas. Let's pretend that these M&Ms are molecules. These are things that make up matter. Can you see these M&Ms?
Yep, they're on the camera.
Okay, when these 3 M&Ms, or 5 M&Ms, are together and they're moving, they're a solid. They're just kind of shaking. But then when they become a gas or a liquid, they move around a little bit more. They're not such a strong bond. That's why we can walk through liquids. They take on the shape of their container. Solids keep their own shape. They still are moving. They're just shaking a little bit, but they're still moving and they're bonded together. You can't go through solids unless you're really strong. You break them. Liquids, it's easy. And then the third state of matter that we talk about is a gas. And that's where these molecules try and fill up their container. They would be flying off into the sky if it was a gas. And there's not a lot of really strong bond between the 2 molecules. That's why we can walk through gases like air really easy. Now, how does it change from one state to the next? How does it change? By adding or taking away heat. Think of it. If you're standing there on a plate, a metal plate, you could be standing still. But if somebody were to light a fire under that metal plate, then hey, that plate's gonna heat up and you're gonna be moving. Woo! Kind of like that. When we add heat to our molecules, they heat up, start moving, and it'll change into a liquid. If I add more heat, they jump into the air and change into a gas. So water is the most common place we see this because it's not a big temperature difference between solid water, which is solid H2O, which is ice, liquid H2O, which is water, and gaseous H2O, which is water vapor. So we're gonna just take some warm water. Let's put her right over here, back on our pumpkin of science. Are we ready?
I think some rotating.
Sounds like popping. Like
Oh, will the middle fill up with orange? We don't know. Okay, you can see that orange is starting to grow out from our Reese's Pieces. That's because that solid outer coating, that hard outer shell, is beginning to liquefy because the hot water is making the molecules move faster and faster.
You should have it.
I just want to eat them.
Almost, our pumpkin's almost done. They would still taste the same.
Hey, Grandma, are you cooking pumpkin?
Oh, Grandma's not cooking pumpkins today, Sonny. Just eating Reese's Pieces.
And they're shaped like pumpkins.
You just walking up like, hey, are you eating anything healthy? Yeah, pumpkin.
All right. I think we have a pretty good pumpkin here. All those colors just melted to the middle.
Well,
They heated up and the outer coatings of those Reese's Pieces started to turn into a liquid. And they melted and they went in the middle. It almost looks like we could see the ribs of the pumpkin there. It's just those colors bleeding. That's pretty cool. Anybody want a piece of pumpkin pie?
yeah. Yeah.
All right.
There he is.
There it is. There's our pumpkin. Let's take a picture of him. Now's the time you've all been waiting for. It's time for the mad scientist and his assistant, Rocking Roland, to test the theories of Galileo Galilei. But before we talk about that 400-year-old scientist, we need to talk about Sir Isaac Newton. Sir Isaac Newton is renowned for his theories on gravity. Do you know what gravity is?
What is gravity?
It's a force. It's an attraction between all objects that have mass, all matter. Every bit of matter out there has an attraction. Now, the greater the mass, the greater the attraction. So, this orange here, it's matter. It's a solid. It has an attraction to you. Do you feel it pulling you in, sucking you in with its juicy, yummy goodness? No, you don't. So, because it's not that much. The size of this planet, when you jump up, you go down. Yes, that was gravity that pulls you down. It's pulling your whole body down. So gravity is that force that attracts us, and it keeps us on our planet. When we drop our orange, it makes it fall. When we spill our milk, it makes it fall. It keeps our planet revolving around the sun. It gets bigger and bigger. The bigger the object, the more gravitational pull it has. So, when you drop something, it falls. Now, the theory we're going to test, we're not going to test gravity. Well, we are going to use gravity. We're going to test Galileo Galilei. He had this theory that all objects fall at the same speed. All objects. If I'm going to drop this pumpkin and this orange, they'll fall at the same speed. What do you think of that? Is that crazy?
Yeah.
Okay, you might think, well, that's crazy, because if I drop this piece of paper and this orange at the same time, what's going to hit the ground first?
Orange.
You're right. The orange hit the ground way quicker. Well, so did we just prove Galileo Galilei wrong?
Yep.
No, we didn't. Because in his theory, this only happens in a vacuum. A vacuum is a place without any air in it. Because why these didn't fall at the same speed, 9.81 meters per second acceleration, was that the air is holding that paper up, where the air doesn't hold the orange up. So the weight really doesn't have anything to do with it. It's how much air it catches. So what we're gonna do is we're gonna take this pumpkin, George, and this orange, Bob, and we're gonna drop them from the top of the school and see which one hits the ground first. And we're gonna videotape it. Then we're gonna do it again in slow motion just to see the cool. All right, so these both are pretty much the same shape. This is heavier, so some people would say, well, it's heavier, it's gonna hit the ground first. But really, they both have about the same wind resistance. Maybe this one has a little bit more, but we're gonna try them both at the same time and see which one hits the ground first. They should. This is way heavier than the orange. So if weight had anything to do with it, this should hit the ground 3 times more, because this is at least 3 or 4 times more heavy than this orange. You can say 5 times faster. So we're gonna see if this hits the ground 5 times faster, then we know it's weight. If they hit the ground about the same time, we know Galileo Galilei was right. We know that all objects accelerate at the same speed, 9.81 meters per second, when falling due to gravitational pull towards the Earth. So let's go test our theory. All right, up to the roof. Okay, so now we are going to test Galileo Galilei's theory that all objects fall at the same speed. So we got a much heavier pumpkin and a much lighter orange. Color shouldn't make any difference. They're about the same shape. And I'm going to drop them at the same time. And we're going to see which one hits the ground first. If weight is a factor to gravity, well then, this guy should hit the ground way earlier. If it doesn't, well, hopefully they'll hit close to the same size. Are we ready?
Yeah.
Let's have a countdown. 3, 2, 1.
Go!
Whoa! Did they hit the ground at the same time?
Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Melia Science.
Science.